Hello guys, this is another thoughts, optirants, because I have nothing better to do than uh, just, not being angry at things, just ranting about, being too philosophical, or maybe, I don't know, having some peculiar thoughts about things and some realization and some, I don't know, some thoughts I thought were interesting and I called them musings. Musings of the retro LARPer. I mean, musings. What kind of word is this musings? I must have remembered musings. A period of reflection or thought. Because there was this X-Files episode. Musings of a cigarette smoking man. Oh god, I have a long time to. I don't remember this episode, but it must have been one on the main plot line. And somehow the word musing came to be like, deep thought or philosophical thoughts or self-reflection or something. And I was thinking about, my retro hobby, something I call retro LARP, the nostalgia thing, but the thing people say, oh, you have rose-tinted nostalgia glasses. I was thinking again how my hobby is a bit of mental masturbation sometimes, and that's okay. I mean, there's a certain path I've taken with things. Why I like the retro stuff, the retro coding, why I am obsessed with performance, or when someone is pushing an old machine, it fascinates me. Or how, from one point, I think we have forgotten how it used to be, how people used to code, but from another point, it's a bit of retro masturbation, or trying to make things crazily fast. Sometimes you don't need. Sometimes you do need to care about performance. That's another topic. But sometimes we look at retro stuff from a modern perspective, and we try to mimic what was happening at the time. And it's fine. It's fine when someone succeeds. It's interesting. It's interesting what people would do today with today's knowledge if they worked again on the old hardware, which is what's happening with demo scene and also retro game dev communities. But sometimes there is LARPing in many directions. First, my favorite kind of LARPing. I cannot find. There was some post. This meme. How it used to be, how you remember it. No, your meme. I cannot find it. Okay, maybe it's not. Maybe I cannot find it. You have this different. I found a map. I found a meme that was showing 3 screens. So it goes. How first it might start. Okay, how we imagine Doom to be. We used to imagine with rose-tinted glasses that Doom was like that. Oh, it was amazing. And now how the indie games, this modern indie game where I'm going to use a Unity engine or an Unreal engine and make it look like retro. How they reimagine that Doom was like that. Oh, it wasn't that like Doom was. It had low-res textures, That was how Doom was. And how Doom actually was. That was how Doom actually was. But, the meme was saying It was about our retro LARPing. There were things that happened 20 years ago and 30 years ago. And people with nostalgia tinted glasses, they remember this thing. They're like, oh my god, Doom. That's what they imagine in their head. And that's the joke, actually. This is the retraced version of Doom. I've tried this one. And it also uses more high-res textures than normal. My version didn't. They have changed them. In JSON Doom, you can add different textures and even normal maps in the classic Doom engine with some. So the joke was people imagined that. It was really that. Which for me it's okay, but people will go and look. Ooh, that looks horrible. This imp is that an imp? It's like 10 by 20 pixels. I can. Why is there so much aliasing? If you see this moving, you will see a lot of aliasing in the design. If you actually played it on the PC in DOSBox or even better on an actual monitor. But the good thing about Classic Doom, the textures were really good. They were not this thing and no lighting or so. And some of these look garish anyway. But they were more like this. But you could see the detail. They had texture. The floor were 64 by 64. This part was 128 by 28, and then it repeated. So they had really good textures. Really good texture. Here's that texture with half of it being greenish because of the. I mean, for its time, we might think, oh, it's low res. It wasn't that low res. They tried to do the best. And people, that's a joke. People in the game recreation, they intentionally make that's the joke, of course. That's an exaggeration. And that's an actual Doom mod, an extra mod, Chibi Doom. I think it's called Chibi Doom, which replaces the enemies with Chibi, and those are also voxel enemies. There is in JZ Doom you can add voxel objects. Someone actually make a much better voxel Doom. Let's not forget it. That was the joke, voxel Doom. They replaced all the monsters. I don't know if I have a good with voxel monsters. Oh, maybe that's a texture map. Or was it? Yeah, I need to put some big. Someone took the time. Isn't there a close up? What? Look at the rocket. Which maybe it looks alright. For it retains this. It looks weird here. This pixely version is not like the attempt to make. Someone did before an attempt to make polygon based Doom. Even the switch has depth. So I'm not sure. Anyway, you gotta see it. I'm just looking at random pictures. Voxel Chibi Doom. Yeah, that's where this one is. I missed it. But that was the whole irony someone posted. All these indie games, the revisiting of the retro indie FPS where people are trying to make things. There are some good artistic stuff, but they are trying to do things like it used to be in the past, but it runs in Unity engine and Unreal engine. I'm trying to find some good examples. There are some interesting ways, but they intentionally make the graphics retro. Now, this is not, and the fun is, yeah, I remember this one. It's not bad. I enjoy this Prodeus. This one, they intentionally make to try to make things pixely, you know, without filtering. But then they add blood decals that do normal mapping and lighting and bump mapping and whatever, and reflections. The enemies are like old Doom, where it was 45 degrees, but they are rotated. There are more rotation angles, so it's kind of a mix of that, and it might look interesting, but there is this kind of fakeness, this kind of LARPing that I'm talking about, and I'm not criticizing, because at the end it's people can do what they want, and I enjoyed some of them. I enjoyed some of them as a game. I enjoy, that's Dusk, isn't it? I think that's Dusk. It does. It's written in Unity, but this is a bad screenshot. Dusk was the first game that tried this. We are retro FPS, blast from the past, but the first one that I liked. And it's not about the graphics, which try to be like Quake, and maybe the game thematically tries to be like Blood or Redneck Rampage or both. But in many places it had such level design and such exploration, such ideas and all the other things, the movement, the fighting was, but it had what the indie games were missing, the indie FPS games. So it was the first time I thought someone, okay, retro nostalgia, LARPing, but this guy did it well. It wasn't just some cash grab. We are like the past. We remember Doom, okay? We are still part of the club. IDTQD, IDKFA, the double shotgun man. Yeah, Doom. Because people remember, oh, Doom was about the violence, but it was that level design that makes you want to explore. That it could be crappy graphics, but it had certain levels and certain. While I don't feel the same about a lot of other things. I don't feel the same. Okay, Proteus, there are some places you go and you shoot stuff, but it doesn't make me want to explore the levels. And also about the fake thing, I got this game a long time ago, Project Warlock. It's very Wolfenstein, so it doesn't. But cute graphics, cute old school stuff, but it doesn't make you. It makes you want to go through this very squarey. The levels are very squarey, and just blast stuff and see the new enemies in the new environment. It has some nice environments, but it's. I don't mind the pixel. I don't mind. But there was one thing. So simple. It was written in Unity, and my God, it was very beefy for my system. It had some performance issues. Something was totally wrong with the acceleration, and even when the frame dropped, the mouse would be timed wrong based on the frame rate, something like that, and it would be floating with the frame rate. And I'm like, it wasn't just that, okay, I'm putting my modern GPU and modern PC into something that barely can. If I had an older GPU, the frame rate would be suffering for such a simple pseudo-retro thing that needs a beefy PC. But it made the experience fun. Also, there was an attempt from the creator at least to fix it, and I have not seen for a long time. Maybe there are more updates. I stopped playing. I play a few maps, even if it looks nice, but it's all squarey maps. There is no exploration like in Dusk, and now this looks very simple because it's an outside, but there are some really good places to explore with secret stuff. That was the time I saw, okay, at least Dusk did it right. Now, Evil was interesting, but I haven't. It had some interesting aesthetic with the graphics, but again, it was mixing the Unreal Engine with retro pixels. And maybe that's I don't mind. It might be better because if you try to do something like Call of Duty, it's going to look boring. It's not. So a lot of creators try to. Yeah, it's a bit. They try to mix things to say I'm doing something unique. So you said there was a game. I can't find. There was a game. So, some games try to change the palette to something weird. Yeah, that one, Hellscreen. I didn't play that, but it's trying to say I'm unique because I have this red and cyan palette. It's like CGA, but not exactly. But I mean, okay, if it's a game is good, I haven't played this one, and I appreciate the attempts. Iron Fury. This goes great because first it looks better. They don't try to intentionally do retro stuff, but this is not intentionally retro. This is using. It's not a okay. It's not some. It's not Unity Unreal. It's not their own engine. It's using the Duke Nukem 3D engine. It's new, and it's using the Windows port of the Duke Nukem 3D engine with some extra stuff, and they try to add the if you see some enemies and some this might not be good screenshot except from the weapon. They are very highly pixeled, even more high res than the Duke Nukem 3D, and they do some extra stuff. They have some voxel stuff. They have some for some items, other stuff. They did some big sky boxes and some they try to do something good with they try to enhance the Duke Nukem engine. Let's see if I can find good screenshots. So these guys took the Duke Nukem engine and they tried to do something good with it. And it played really well. It had the level design. It had the interesting interconnected maps with unique Easter eggs. So they tried to do something better with the engine, which I appreciate. And because it was the Duke, it wasn't like I'm using Unity engine to do something that looks like Redline. It's like I'm using the Duke 3D engine, and I'm trying to use even more high-res texture than the original game. They are retro, they are old school, but they are high fine pixel art. So I'm trying to do something good, and I'm trying to do not a nostalgia, very linear FPS, but like it used to be. And I think this is the second indie game that got it for me. The first was Dusk, the second was this one. Medieval is interesting, I want to play it because it has very unique architecture, very unique aesthetics. It's something weird. And I guess all these indie FPS are trying, and it's interesting to see and I started about something. Oh, look, I was saying about this one. This is how retro games were. The texture had good fidelity. They tried to do the best. This is our nostalgia glasses, and this is how the indie games make it to be. Like, oh, it must have been as low as that. And I was looking, this is another one, Strafe. I got it, but I didn't like it at the end. Again, they tried to play with the. It's like in the FPS. There is a lot of frantic battles and blood and stuff. Yeah, like we are missing violence from modern FPS games. Yeah, right. And but it's retro, and they plaster. I have seen even some other picture in the weapon. Some very low res textures. Very. This was even Quake didn't look like that. I don't know. Maybe it did. Maybe Quake did. And you get there are some other stuff. I remember some other texture worlds that were low res, very low res. While Doom had a good fidelity in its texture. So the original, the retro. And there was another one. I was watching. There was some guy, some podcast playing some old Amstrad CPC game. There were some French games from in Amstrad CPC that they were crappy games in the most Amstrad games the scrolling is very low, the sprite movement is low FPS, for various reasons. That game had mode 1 graphics, but it wasn't mode 1 320 by 204 colors. It wasn't. People say, oh, these are the ports from Spectrum that use similar pixel fidelity and very few colors. And the low resolution of the CPC is 160 by 216 colors. But this goes 320 by 200, but it was pixel art that the Frenchies were done. It wasn't ported from. It was some, even with a French title, I think. It was some game, some weird game, maybe unplayable, but the pixel art was so fine. It was so good with the 4 colors and the dithering. And the guy said, look, at that time, these people, you think this is retro, but they were trying. They were trying with the limitation to do the best. And this is what Doom is. And it made me think. We think of Karma, we think of all people say, oh my god, they were pushing the... Yeah, they were pushing the hardware, and that's it. And the old school thing is, you did your absolutely best with what we have, but we see it now as retro. And here's the thing. We see that now as retro and we mimic it, but we do it worse than it used to be. We do it. We use the modern PC Unity Unreal engines to make something that looks like the old, but it doesn't perform the way it used. That would be like Carmack being in that time and not doing Doom, but looking back. Oh my god, the Atari 2600, the Atari VCS. Those times, these heroes were doing these amazing things with retro pixels and this limited. I'm going to make an Atari VCS game looking like an Atari VCS game that runs in my 486. It's going to look like retro, but it's going to run in modern PCs. Okay. But so we think of Carmack and other programmers like heroes of the retro, but they were coding heroes of the times. Okay, where they got the latest thing they could do, but they try to do the absolute best. We see that we see. Look how old computers were and what they can do. And now this retro nostalgia is like, I'm going to do it like it was, but the second part of my video, because I was thinking other things about demo scene and things I'm doing also, which I do mental masturbate with code, but I'm going to explain what I mean. This is related with that. Even in the demo scene sometimes, some retro platforms are really pushing. Some other retro platforms, I'm not sure anymore. I don't know where to start with that. I was thinking, I'm happy that there goes a revival. There is a scene I'm missing, and the scene goes the MS-DOS scene. For whatever reason, and it makes sense. People stopped making enough those demos, and I have put here demo because if you remove that, can I remove it? If I say MS-DOS, maybe put the gas too. You see, most of them are 256 bytes, 128 bytes, because that's the most, and that's fine. And Those are going really good, I think. Those are going really good. This is a crap I made. I'm looking at stuff. Because you see new and new. Okay, sometimes it takes a long to see something really good, something that impresses you to get, but there are some of them that are, also the nature of them have changed, that are still pushing. They are pushing the size optimization, and I mean, the most famous now. Oh, whoa. Can I have only the 256? Ah, yeah. It used to be tube. That's a class, but it's now memories. Okay. And this is, in this one, they managed to put like eight effects or 9 or how many in 256 with music. So this is way ahead than the old ones. Although the old ones had they were searching more to do some right textures and colors, and but if you see the history, there are some recent good ones. So this scene never died. The 256 never died. What died at some point is the classic DOS demo community. I had a long time to see, but there was some kind of revival. Okay, maybe you still see a lot in the year, but I mean, I think after 2000, 2002, you still see. But if you go to the previous year, maybe I needed a graph, and most of them are. There is this ISO group which makes this joke stuff many times. Where is one? Yeah, it makes this joke stuff that I never watch. And from time to time, maybe there is something, but it went 2002, 4. So there are demos to go. Look, from 2004 to 2011, very few, and a lot of them are bits. Okay. Now the DC5 are fine because they are made in quick basing and they are really interesting for quick basing. Maybe some ASCII demos or something, but nothing very serious. There are some serious here, like when Trickster was pushing the 8088 and he still pushes it. Those are the only ones that really push. They push the 8088. But at some point, there was an assembly party. Okay, there are things, but I'm searching for assembly. There was a competition. 2000. Okay, I mean, now this is too far in time. So there was in assembly old school demo. And it's not old school DOS demo. At some point assembly started having old school DOS demo or old school demo. Maybe old school demo in general, it was never a DOS. The only thing that happened is that besides the Commodore and the Amiga and so on, they said we have, here is another one. We have a DOS hardware now. And maybe the hardware was a 486, maybe now it's a Pentium. There is one those demo. Yeah, because you know the interest is low. And I'm guilty of that too, because we wanted to make a DOS demo too, but every year we say it. So my thesis, maybe what I wanted to say, is that because the PC DOS demo dropped and people stopped doing it, when it came back, there was some Byte Rappers did some demos, Byte Rappers, and I was a bit amused because I was looking at some of their demos. I was like, yeah, another old school demo on PC, on DOS PC. Yeah, I have a long time to see it. And there was one or two comments that were saying, I don't know if it's here or no, like it was most positive. Like, that's not like the past. This is. I remember much better demos on my PC, faster with better engines and not underperforming. And now you need a Pentium. And the other joke is, I've heard some people, for the assembly old school combo, DOS Pentium. For the DOS Pentium with it didn't have an MMX. Some people ask for an MMX. Or why can it be a Pentium 2 MMX with 64 megabyte of RAM? And I'm like, is that old school? And what I don't see is people pushing the 486, the 386. There are some attempts, but I enjoy those demos, but I don't see. I run something that is worse in performance, especially, than what I could see on my 486 at the time. Or the Pentium demos. I remember the best. I'm not a, yeah. It might sound a bit like yeah. I don't want to. This is lost. I mean, nobody is pushing this DOS PC like they used to. But we have, of course, this problem. If not many people are doing, for example, to change the sound. The exception is the Hornet, Trickster and his friends, and Trickster, Scully, and all these people who are pushing the 8008. Yeah, this is the exception. This is the only time. Okay, I see someone trying to really push this hard, but the 8088, we haven't seen something for 286. There are some nice 286 demos, but I think there is more could be done. I think the classics were much better effects, much better performing, and it's a shame I couldn't put myself to do something for 286, because there is a lot potential with 286, 386, because I was trying some stuff. Remember I was showing you the video with the sphere map. I was trying a sphere map. Yeah, and maybe DOSBox doesn't make a good. It's just a sphere map. It's not, and this might be a bit slower than in my setup. I was getting like 200 FPS or more. Sorry about. And I was thinking, but recently I did something, and in this video I tried to. So this is an IBM XT 8088 at the 4.7 megahertz. Okay, this is how it runs if I wrote it in C, but I changed my approach though. 2.1 FPS. And then I ran the assembly version. Let's move it. It has some. That's my setup there. And this is on the XT. You can do a regular pixel sphere mapping effect like in second reality. Pretty smooth as much as it can be. It can get 22 FPS. Now can it get better? And my approach, it wasn't something magical, but it's something that people will not do. So I don't think I have my C code anymore. But I had some code that generated the assembly code, which I uploaded. And the C code was also a mapping, but it would have some edge list in a way. That's it. To avoid the transparent pixel and going in the intersection on the sphere with the horizontal scan line. To start a bit later pixel and then use a map to map and read from the background. And it's also doing a bit of like dirty rectangles, but it's like dirty rings really. I wanted to make a video about that, but I didn't. I wanted to make an OptiRantSophy video. And I generated a code that is like, okay, first of all, it's like that. And this is how people, it's not novel, it's how people do things on Commodore 64 and other 8-bits, where they make unroll for every pixel. And, hold on. These are sections where the eye is pointing to the... No, SI is pointing to the video RAM and the eye is pointing to the background. And these are sections outside of the sphere but nearby. Because as I move the sphere, I don't clear the background, but the dirty areas around, not dirty, clear. It's going to copy pieces of the background to erase the previous area the sphere changed, so that I don't have to clear the whole sphere and create a mask in the background and write again. And then it enters the part with the sphere where it reads if the pixel it will map will scale to B, it reads 2 pixels here. This is stored in a register to add and get the BX starts at 64, I think. I'm passing it. So if the background colors are from 0 to 63, the sphere colors that darker blue is 64 to 127. And I have made the palette accordingly so that I read the background pixel, I add 2 pixels out one here and I write. And sometimes here I read because the offsets are different. Although now I see I must have made a mistake. This could have been this could have been that. I need to see that. But later, when you see the offset go far away, so 1 pixel, the sphere will distort and from this is the base offset that is the same, is the one at the background pixel that you are going to write, but it will go offset in the background and read other pixels. So basically it's unroll very, very, very speed up without reading any lookup, directly in the code, hard-coded speed up to instantly read pixel mappings and store, and pixel and store. So that was the approach that made a regular algorithm that's still used. The regular algorithm is still used to look up tables. Oh, now in another part. I still have x offset and x length, and I might be storing. Where am I storing that? I might not do that anymore. This is the pre-calculation of the sphere, and I store DST. Ah, I have the sphere map. How have I not seen it? I'm doing the dirty thing. Okay, I have to malloc it. But I'm doing, because on the assembly code I point to that. So, and in the C code, which I don't think I have anymore, I don't have a render sphere anymore, the C example, I would look at this map and get the offset from the map and get the offset from the screen. So I would do some extra, and even that I try to optimize, but, and that is the compiler, but you have seen the difference, okay? You have seen that the C code would run like this, and you would do that. Even if you wrote this approach in assembly, you will still be like, oh man, you can't do anything in XT. And then I will show you that, and you are like, how is this possible? So there is a lot of potential. This is, I tried to optimize this for 286. The first version of 286 was doing 25 frames per second, the C version. And then I'm doing this assembly, direct and roll code on 286, and I thought I would get 50 frames, and I thought I was get to 50 or 100. I was a bit cautious to not overshoot my expectations. Then I get 200, and then I found more stuff for 250, 270. I got it 270. Okay, it's a 286 at 20 megahertz. Not this one, but the other one I was trying it. And what I want to say, you see that? Then I'm doing experiments in. I don't know what else I have. Do I have the roto? I have the roto. Oh, the. Maybe put the 25. This is a rotozoom like second reality. It's 160 by 100. I'm using mode X now. I figure out how to use mode X to write double picks, and I try to make them column, the odd columns and then the even columns. It's I think it gets more on my 286. And this is DOSBox, and it might, or maybe I run it with vsync on. It doesn't matter. I think I get it 67, but in the 286. I did notice if you put the core to dynamic, things are a bit faster, but you have to try that on a real. And I even did a high pixel, 320 by 200. That would get 17 FPS on the pixel resolution. On the 286 at 20 MHz, of course, it will get less, okay. But on 386 it would get better. Maybe I had vsync enabled, no. And I was doing more expansion anyway. And then that makes me think, when I see some Pentium demos, I guess people, that's another thought of mine. If I wasn't so obsessed with making things fast and I released a demo, I would have released more demos. Maybe that's the idea. But then I wouldn't be as motivated to work on a demo. Because what motivates me is that. Also, I wanted to say about the retro nostalgia. I was looking at later. Even if I'm very positive about these demos, I thumb them up. I was looking at. There was a list of high-res software render demos. Some of them are good. Okay, some of them are classics in DOS. But some later on, when things are moving, those might have been fine. But when we reach this era of 98, 99, and some of them are really good demos. I would run demos that on my Pentium 1 would crawl. And it's a good Pentium 1 at 166 megahertz and MMX and so on. I would run some demos that some of them wouldn't go. And they have this new style, this maybe that would run okay. Flat shaded polygons, things that on first view you would say, this is flat shaded, man, this is flat shaded, why is it going so slow? And it might be like, you know, it's in high res flat shaded, and you know it's that noise effect, it's the layers. Okay, but I like to watch this one. Okay, this has more stuff on the screen, but a lot of these demos were letterboxed, so it was like mid-res, maybe it's 512 by 384 or 640 by 480, but the screen was so squeezed that it was really less pixels. And I say, okay, that should be good for the Pentium, and it was slow in the Pentium. You needed I don't know, Pentium 2 with, and that's okay. And those are not, that's okay. It's not the worst. I remember at the time, and I was complaining. That was the replay demos, and they changed the style. They did this. Let's make. That's an accelerated. Yeah, let's make some. That's a classic. I like the music. Flat shaded thing, but it was slow. Pentium 2, 3. And you might say, it's not so easy, man. It has the layers with transparent. No, you could do that in a Pentium 1. And the other thing I noticed, and that's back in time when people were still trying to push it. There were some things that really pushed it, and there were some things that were doing more the look. I'm doing flat shaded polygons, but like I could do them on my 286. And I noticed some kind of decline because I was doing those things. I don't know if I have something else. I was doing some things here, and I'm like, if I can do I have a regular plasma here? Let's say if I can do on my 386, but that's not a representative, okay. Or the 486, if I can do this. Did I make with the plasma? Maybe I didn't. I still have the rotor running, I don't know. If I do the plasma 200 FPS on my 486 and I do the... Okay, it's always the plasma. Now, the second half of this video doesn't make any sense. I always feel there is more. Finally, and maybe it was always like, maybe back in the earlier, maybe which were the best demos? Maybe now I will counter my argument, okay? Maybe when you have the best demos, when you have the stars in 95, and I would see some crazy 3D object on my 486, big, huge. I mean, the B might have been a lie, but or other kinds of the demos. Crystal Dreams, of course. When I was seeing some of the good demos on 486p, on the Pentium you have, you know, hyperventilation. You had my favorite was Boost. I do remember, maybe I misremember. Look, that demo might run on a fast 486. So there was a possibility you could run these crazy 3D scenes on a 486. Very slow. Might. It was a top Pentium demo. But there was a possibility. It was even with a 15 or 16 bits color mode, which makes things even harder. $16 megabyte UABB. Huh. Okay. There were some demos that were like much later you would see similar things in 320 resolutions. But you would require a Pentium 2. And previously you had Dick's project. They tried to do on the 486 640 by 480. Okay, maybe you needed a Pentium for that. But they tried, okay. They also do countdown. They push the high resolution. There are some stuff that I could run on high resolutions. And they would... The low resolution easily ran on a 320, on a 486. And they were slow on a 386. It was possible to run these demos in the 386. And maybe we haven't seen everything because... do I have it? I was watching Amiga stuff now. Man, okay. The Machiavelli, the Thug Life. Okay. It doesn't say. This was for 680-083. I ran it on my 6083, okay, at 50 MHz. I think the 680-083, first of all, it's like a 386. It's equivalent to a 386. I even look at the cycles of specific 68,000, 68020. Man, some of the cycles, have you seen the mul and the div? How much slower it is than the mul and the div of a 286? And some of the other instructions, even on the 0 to 80, I was looking at stuff. The shift would, if you shift several bits, it matters for performance. Compared to 386, that it doesn't matter anymore. You see, and you're like, those were not, they were better processors in some ways, much nicer to program, but they were not faster than the Intel processors. You think that, oh, Intel must be horrible because, and that's why performance suffers, but again, it was because of the Amiga, the early Amiga, it had the custom chip, and you could see things that would be very hard to pull on PC, and on PC you had to do pure software in it. But then you come in this era where they try to match the PC, and these people, okay, this is kinda how it runs on my, this is not on 040 or 060, this is on 030, I've run it. Full screen polygon scenes, full bump mapping. My favorite, look at this object. Okay, it's not 30 FPS, maybe it's 15 FPS, but look, big pixel resolution, smooth pseudo-functioning environment mapping with this blob, okay, and the texture. This is 486 level. Very, very smooth tunnel. Look at this bump mapping. Huge bump mapping, big. It doesn't show it far away on the screen so that it's few pixels. It fills the screen with colorful bump mapping. Okay. Big scenes going from planet to planet. This is those are the Amiga demos that made me believe. Okay. What is maybe plus slow chip RAM to write a pixel freaking bit planes. Of course they are fast. Okay, we have faster chunky to planar. This is an exit tier demo. If you show me this, any scene of this, from the objects, pixel res, bump mapping, at this speed, and you say, I ran this demo on my PC, I would say it must be a 486 if not a Pentium, isn't it? No, it's like a 386 with slow ISA card and bit planes! Do you understand what we can do on a 386? Do you understand? I'm not angry. I'm just obsessed with the idea. I just love the idea. I don't think we have pushed the PC. And I'm not arrogant for myself. I just going to. Okay, and I started talking about the retro LARPing and stuff. And that I do mentally masturbate with all this optimization stuff. Okay. This does run on 386. Some of the stuff in this could run on 286 well. Okay. I don't have it. I made the sphere mapping bounce on a 286 at 200 frames. I made it bounce on it doesn't bounce. It move around at 20 FPS on the XT. I can have two spheres. I made the rotozoomer fast enough on my 286. Maybe it's 10 frames on the XT. And I haven't finished, okay. There could be more. Now, those retro demos, I think you could run it lower. Maybe, maybe they have transparency. Maybe it's the way they program. They are programmed. This could be possible. Actually, this runs on a 386, but slowly. So maybe it's not a good... but this could run on a 386 if it doesn't. Even demos like this that need Pentium, they could be pushed to run on a 386, 486. You could push it to the end. I'm a bit arrogant and I don't know. You know, everything you remember on the 486 on the Pentium. I mean, you could do something that looks like it. Okay, maybe it's LARPing a bit. Maybe they say, okay, those scenes don't have enough polygons, but do a regular engine filling the screen with texture mapping, and most people will make it run 2 frames per second on a 386 and 5 frames per second on a 486 today. And they might like, why does the assembly, where is the Pentium 2 MMX? And it might be because, okay, if you take a modern engine and port it, you see, man, it's slow. How did people do these things on the 486? This is, the Amiga is worse. This is like, the machine I ran this and it runs relatively like that, was like a 386, but worse than a 386, because of the bit planes and the slow chip RAM. Okay, the 386 had the ISA card, but at least you had the chunky. And I have kind of proven it because I was trying to do, but I must complete my 3D engine. I could do a big Guro shaded cube. That's for the filling, the rasterizer. Okay, I must do something with more polygons at some point. And I could make it run fast on a 286. You can have Guro shading on 286. You had some slow demos with the 3D torches on 386 that you rather watch them on the 486. They didn't perform, but they ran, but they didn't perform very well. Even at the early time, I think I was watching. I was watching this one. This is nice on 486, but it's very slow on 386. It barely runs on 386. I mean, okay, maybe I have to do it myself instead. But those Amiga demos are the thing that believe. But then with Amiga happened the same. They moved to the AGA demos, and you might see AGA demos that don't seem to do much better. But no, they do some. It's like the way of coding has changed. You just get a generic chunky to buffer and just write everything there. You might have some minimalistic AGA demo that shows some flat shaded polygons, and they run like crap if they run at all on my 68030. I think so. I think there was a period that few groups were pushing the 68030, and before that, some group were pushing the 68020. And then everybody moved on the modern stuff, and we might have become a bit lazy. But maybe, it's progress, and why would someone bother? I mean, you can make something that looks retro or artistic, and you might be like, whoa. And even me, I see those demos and I give thumb up. And then I see sometimes one or two person complaining, I think this machine can do more. This is underperforming. And I'm running here, but I'm not running there. And that's fine, just. And then it brings us to the modern PC. I was looking at some. I don't want to say anything about people's demos because they're doing it for other reasons. They might not try to post, but we stopped seeing software demos on the PC, on the modern PC. Why? Why would anyone bother? I think the last one I saw, at least that's a nice attempt because, and I can verify. I do applaud this attempt. This was a recent software demo, but it's 720p. Some things are run really smooth, and anyway, most of the stuff are very shader-like, so I can't attest how well optimized. But it's new for software because I was and it's interesting. The code is out. There are simmed optimization. There are modern approach to software rendering. Okay, and it's smooth. It's smooth in 720 because there was a period that I would look some from the majority of the PC demos. Sometimes you see some software render demos. And I'm not talking about the recent JavaScript software render demo, which at least it's a different JavaScript, and it might be a struggle to do a good software demo there. And those were better in a way than the Unity Unreal demos in the same competition, where it started getting interesting. It stopped getting interesting. But previous year, rarely people will attempt software demo, and I would see things that were. I would see demos on Windows software rendering very rarely. Okay, very few people are trying, I guess, and maybe I should not discourage that. I would see things that are like, that's so slow for even for software rendering, and maybe people will say it gives the wrong impression. It gives people, you know, software rendering is hard. It's slow because software. No, I don't think anymore. I think it's you don't even need to do crazy tricks. Because okay, those are what is this, a plasma? Again a plasma. You're doing a plasma for all years. Because I'm running. Okay, I have parallelized it, and I don't know much about parallelization, but it's gonna have bumpy frame rate as well because of this diagnostic tool running. And this is a 1080. I'm in 4K resolution and it's 1080. It might look more, but I have a magnifying 1.5 on the desktop. And this is, look at the frame rate. I can do this kind of effect and get, okay, maybe I'm sitting by, let's make it single core. 1080 single core. At first it's jumpy, the frame rate is jumpy for some reason. But maybe because of that's the thing. Recently I started testing things again. And there are processes running that are make the frame rate fluctuating. And for that reason, might try to run it outside of. It's a bit smoother at start. That's about the frame rate, 360 or something, with fluctuation. This is 1080! And I'm doing all the things that people say not to do. Oh, you're using lookup tables. That's not good, man. This is something you did in the past. You should use sine and cosines and math. Everything is fast now. The compiler will figure it out. Okay, and no parallelization. Okay. Now I'm doing parallelization, which is I don't even know much about OpenMP. I'm not an expert. To get the most, maybe you have to learn more about it than just using OpenMP. I don't know. And it goes like 492. Now it didn't. My PC has like, where is it? It's full utilization. It has 4 cores and 8 with hyper-threading, I guess. It is an i7, this i7. Okay. And also there is the overhead, of course, of the rendering of the. So purely calculated, I put it here to see. This is a bit, okay, this is a bit huggy way to see it. It does say 1700 to calculate this plasma in 1080. And then I put it, let's put it full screen, 4K. I'm gonna copy this here. Full screen 4K. 140 FPS, full screen 4K, 8 million pixel calculation software render. And you may say it's a crappy plasma that repeats itself. Okay. Thug life. Close that. No. Okay. This is not serious. People are doing more serious stuff. They have a lot of filters and how is it called? Glow and hypno glow and okay, a very emetic RGB plasma 118. You know, if I show this to people and say this is running in 4K and they saw the frame rate, it's on shaders, isn't it? In GPU. No, it's pure software rendering. Their jaw would fall. But I'm not doing magic. I'm not doing simmed. Okay, I put the parallelization. I'm just doing the classic things we did in the past, like You have this sine and cosine all integer, and I'm not doing. And then the other experiment, I didn't do some magical assembly, okay? When people are like, is it parallelized? I tried the roto fix point like I used to do it, in the 90s, but no tricks, no unrolling, no, just regularly. And I'm doing all this crap work to get the nearby from the 4 pixel. Wait, let's run it. Am I parallelizing it? And even if you remove if you want to do a 480, okay, reduce the resolution, make a 480 demo. 1080p rotozoomer, and not just any rotozoomer, bilinear rotozoomer, the thing that the GPUs are doing. That's someone told me at the time, can I do a bilinear rotozoomer on the Pentium? I was like, this is a very heavy effect. It needs a lot of horsepower. You're not gonna do it. That's not the Pentium, of course. I did it on the GP2. I did it in the GP2X bilinear filter with fixed point. This is heavier. This is much heavier than the plasma. You have to do all that crap. So this is not normal rotozoomer. This is rotozoomers with extra step where you have to get the RGB from the 4 pixels. And maybe I'm doing it inefficient here. I don't know. Maybe someone will say you shouldn't be doing that. This is inefficient. But I tried some things. Get the top bottom RGB, do the interpolation all with fixed point. Okay. No assembly, no crazy tricks. But then I didn't write a naive code that does calculation per pixel. Also, you could draw the float. Actually, I tried the float. I say, okay, what if I do a float? Also, and the float, even if you did it on float, it's not that bad. Why am I? Get out. Oh, come on now. What? Did it crashed? Forget that. I don't care about that. This is the floating point. It still gets 140 something. And actually to get... God damn it. To get 140, I kinda cheated because I didn't want to... The argument was, what if I do it in floating point? Is it better to do it in fixed point? I didn't try to... I tried to be fair and do everything. Write the code in different ways and I'll show you. I did use the AVX. If you don't use them, I get 110 frames. If you use them, you get 140. Now, if you do real simmed optimization, I don't think you would get the 40%. You will get 2, 3, 4 times, maybe 4 times at most. You will be lower than 4 if you did it right. It's kind of lazy to say, hey, just put the simmed optimization on the... What? Why did this ever crash? It's kind of... But suppose I don't want to do simmed and I don't... Okay, parallelization, okay. Maybe I don't want to do parallelization and I want to do float. Now, you have to be careful what float you write. Of course. Is this the... Did I build it? Ah, it still does that. Okay, I don't know. I'm not making any sense. So if you remove it, it goes on not set. I also throw not enhanced. Am I running this one? Oh, I was still running the parallelization. Let's remove the parallelization. No parallelization. Okay, it goes much low. Oh, it drops at 30. So there is interesting. How much difference does it make? I think AVX2 is the best I can put for this machine. So it was an interesting experiment, but it does help. It goes to 42, but it doesn't give you. I believe if you write simd on your own, you can get multiples of speed depending on what you do. So the compiler option doesn't give you that. And if you run the parallelization and imagine the plasma doesn't even need that. Yeah, that really pushes it. 144. But then if you run my fixed point version even today, however, if you don't want to mess with fixed point, you can still go on 1080p and do software rendering really fast. And you might say, okay, no, I'll do a 720 demo. You know what I mean. I mean, you might say that's a rotozoomer. It's not the more. This is very old school demo. This is very but you can do 400 frames. I mean, sometimes I think there was a demo. Someone made a software demo, and it was 320 by 200, and he stole some shaders from Shader Toy and just rerun the demo on the CPU on 320 200, and it was like, why? We can do even in 480 if you don't like. You can do a 480 demo that could run a bilinear rotozoomer at that speed, and I'm not doing something magic here. Okay, I didn't do some extreme optimization in assembly or something or sim. You know, I can. The fixed point doesn't seem to. I guess these AVX are only for float. You can be lazy. Now, the reality, if you are very lazy, here is what I'm going to. What the fuck now with the system? I don't even know if it did. No parallelization. Oh yeah, that was it. It was 1000 before, was it? No parallelization 720p. No parallelization, no simmed. Single core, 720p. You can do a nice rotozoomer. 720p. Even with bilinear filtering. And you might say, yeah, but most demos are not. This is very retro. Most demos have many layers with graphics. You can optimize your layers with graphics. If I can make I lost my if I can make with a bit of OpenMP 400 frames here, you can do something at 50. You can be 8 times slower. You can have 8 times the things and still get a good frame rate. And if you want to push it the old school demo scene way, and this is a bilinear filter rotozoomer. If you I'm not making sense anymore. Okay, plasma, nice plasma with no parallelization. Single core 720p. I get 400. It's much simpler than the bilinear filter rotozoomer. So if I see a demo mimicking retro effect. That's the retro LARPing I see. And it's some 320 resolution with a very slow scroller and rotozoomer that doesn't even do filtering. And I prefer the rotozoomer that doesn't do filtering. It's not like I prefer the pixely thing, but if it doesn't, I have to try to make things slow in software rendering in modern PCs. I have to try. But the reason is something, because for most people to go and pre-calculate lookup tables for sign, to do the extra step and make everything integer and render it in integer, but that's how you would render pixel effects. Come on. For most people, it's like very old school. It's an extra step. It's like it seems. Most people, I have some old effects here. I found some very old stuff of mine. Let me show you. This is where I got it. This is the version. This is the same version where I'm adding lookup tables of sines, cosines with the k are some time values from outside, and I'm looping it, and it's a very small loop. Okay, it's very elementary. And I have an RGB, I have a lookup table and some pseudo palette. It's 32-bit, of course, but I made an RGB somewhere here. Nowadays I have a special function to make it more easily, rather than this kind of mess. Yeah, there's the extra step of having a lookup table. In the VGA in DOS, you just wrote the index and you made the palette like that. You have even faster stuff. But this is 480p. This was an old one. 480p. It's very variable for some reason. Okay. I think my windows are doing something, and that frame rate didn't used to fluctuate so much. Something is on my windows. And then I was trying to prove something or make sense of it. I say, okay, what if I go floating point? Because there was like, why are you using integer? Floating point are fast. They are fast, but in certain moments. So fsyn1, fsyn2, but those are floats now. And I calculate them, they are floats, I don't cast them to int. So this CC is a float. The only thing is I have to cast it into an int, and back in time, maybe you don't need to do that anymore. Back in time, the conversion from float to int was much slower, and I found somewhere this code, which I don't even know what it is. It does some magic number casting, and it was a faster way. And that's the only way I could not have a horrible, and it still runs. Floating point lookup tables, additions of floating point. You can do additions, multiplication, division with floating point. And maybe the mul and div is better than the integer mul and div in performance nowadays. You can do it. You have the problem with the conversion to the pixel. But today, if you cast to int, because I tried it, I think I'm doing that here. I'm not doing it. I'm doing it in the rotozoomer. Today, I end up casting. Those were flows. The X-stop, all the stuff were flows. I cast to int, and it is fast. It doesn't have the overhead anymore. They must have changed something on the CPU. So you don't need to use hacks. Now the only hack I used, I previously it was slower because I had to cast more stuff, because the source data was int, but now I have a different source data. I have a float texture, because previously I would cast from texture to read the 4 values for the bilinear, to float and back. And there might be faster ways to do. Maybe you can read 2 pixels at once. And so now I did this, which is a bit crap because now every channel is 4 bytes, so it's worse for the cache. And but this way, because it all went with flow. Previously it was conversion from flow to in and back, and I do have to do the flow ref. That could have a performance impact. So still, when I'm doing for pixel effects floating points, I have some issues that I think that's why the fixed point, even today, can come a bit better. But this works too if you want to go flow. But what doesn't work? You see, there are some considerations. You don't just say, float are fast, compiler are smart, I'm gonna throw everything. Because even today, this one with float, okay, 1600 frames. Okay, it's a bit less, it's not 2000, it's still good. But most people, and that's the version, will say, if you don't have to care about float anymore, in the plasma loop, I'm going to throw sine and cosines, which are the sine of cosine of the math. And you might say, what math did you enable the sim, the optimization, and so on? But come on, nobody's looking. People will be looking, will be getting some pixel shader from shader and throw it in the CPU with all this square root sine cosine. And even today, that goes on 480p. Remember 2000 frames per second, or 1,500 frames for the float lookup table. Put sines, 3 sines, just 3 sines. This is how it runs today in 480p. But I would hear 10 years ago, I would go and write this, the integer version. Oh, why are you using integer now? Why are you not using floating point maths? Floats are fast now. I would hear that 20 years ago. 20 years ago. And they might say, this code is slow, you didn't enable the sim. I don't think. I think these things are still slow. You can just do software render pixel effects and throw your sine and cosines. Unless you do something for a very small bitmap. Unless you do something for, you want to do something on your 3D points. You have 10,000 3D points and you're going to do some extra stuff. To distort them with, do some square root mapping on 3D vertices. And even then you should look it. Because I thought this would fix. Okay, maybe I should recompile. Maybe I should recompile this experiment. Maybe things changed. But I don't think they changed so much that if this goes 17 frames and it changed, maybe it goes 50 frames per second. Which is still much less than 1000. Which is, if I do that effect here, what I get on the 720 or 1080p, I get like 700 frames. It will go 20 frames per second. Previously, it would go 4 frames per second. This is today. I'm not doing a heavy thing. I'm not doing a big shader toy code with 50 calculations. I'm doing 3 signs. Floating point division, the division and the multiplication, as far as I know, they would be equally fast. But the trigonometric, be careful. And I'll say something. I was looking at I was curious about this demo because I mean, Superplex knows what he's doing. And he posted the GitHub code. I was looking, but there are parts with sim, there are parts with... And there were some parts, it goes... I can't find it now. It goes copying it was using some code from Shader Toy, but improved for performance, and it was using lookup tables for science. And there was a good reason to use them, because even today, someone, I'm repeating might see my other code and see. Why are you doing lookup tables for math? This is very old school. We don't need to do that anymore. But if you don't do it, you get things like that in 480p. If you do it, you get things like that, 700, 800 frames in 720p. Okay. We have forgotten how things were possible back in the 486, but there is a bit also of LARPing, and sometimes I might be LARPing too with my nostalgia. So I'm not sure where I want to get to that. And there is a bit of where people come and make modern demos. This is on the Amiga and the Commodore 64 because the scenes never died. The Amiga and Commodore 64, the scenes never died. So every year, some demos are pushing from what happened before. On the little comeback of those demos, I think I see nice things that are worse in performance and even in quality than the classic ones in those demos. They are welcome, of course, because yeah, I thumbed up these demos already because I like that some people are doing, and I should be doing, but I'm mentally masturbating with effects, but I should, if nobody shows, I should show what can really be done with a 286, with a 386, because or even with a modern. I should learn a bit of real simmed optimization, and I don't know if OpenMP is the best way, because maybe I have to make my thread pool with thread workers and do it on my own way. I had this idea somehow that I don't see the plus 4 times improvement, but maybe it's other kinds of bottlenecks. So there is a lot to learn. It gives you something, but not as much. But the thing is, even single core, I can do things pretty fast. Maybe I don't necessarily need it. It would be an extra. Maybe SIMD is the better way, and then you look at parallelization. Imagine how people will do some slow retro thing, and I have slow retro things, okay. I have things that I'm trying for the first time, okay. And I'm writing it in a lazy way just to see how it works. So I do a twirl effect. It gets 1 to a 7 effect, but that's not, if I can do full screen stuff, that's not good. It's not good for, and probably because I was testing the effect and I was doing sine and cosines and double and float and double inside the main loop, because I see there are a lot of I just wanted to make it work. I mostly wanted this to generate unroll codes for another system. I wanted to do this effect on the Amstrad CPC or another, and I wanted to see how it works so that I can. So if I write some lazy code with sine and cosines inside the main loop, it's because that's what I mean. If you write it like this and you don't take the extra step, this is even worse. I remember both of them to be slower. And I know those are both trying. I'm trying to do things with floating point just to make the mapping work, and then I plan to rewrite things in ways that makes it much faster for a demo effect. Both of them I was trying to only generate something, make it go, and I think now because of these extensions, these were much slower. Because they use floats, both of them. No, it's the same. Anyway, that's what I want to say. I have code of mine that is very slow. It's not written the way it used to be, but just to generate something, test something. But things can be blazingly fast, even in software rendering. It's not a crazy feat to do it today. And people can still screw that up. And I guess they are making demos just to, you know, show something, their artistic vision or something. No, nobody obsesses about. And you don't need, let it stabilize. You don't need 700 frames. You need 60 frames or something. But that means if I can do this like that, I can do things that are 10 times heavier. I could do 10 effects on top of each other and blend them. Okay, blending is an extra step. I can do other kinds of things easily and still have the desired frame rate. So I don't know why, and it's so easy. And people think software rendering must be slow. I was surprised myself. I thought all of this. I ported them from the old code I used to have. I have a mega backup with a lot of old school stuff that I might lose, so I collected them to not lose. I have them all around, and I saw, oh, that old one. Let's port it to the new. And finally, before closing, I know this second part, I started talking about games and retro LARPing. It's all LARPing, man. Everything is LARPing in this world. And I'm also LARPing, okay? Because this is an interesting video where some people from the industry, they talk about how they did texture mapping, how you had the 386 and the 486, or even in the Amiga, and you had to do all the wild ways to do. They didn't even know how to do it right, and they were inventing things. Some of them were horrible, but it was something that worked. But they were unoptimal with bugs and different versions. Till someone figured it out, but it's a bit different than what I'm talking. But it was very interesting because it talks about how all these minds, they were thinking out of the box and they had to push something, and compared to how slow computers were there, which they are slow from today's perspective, but back then you had a 386 and 486. If I was doing the sphere map and the rotozoomer on 286, the 486 is a beast in front of it. It's a beast. Okay, I'm trying to do the grow texture mapping shader on texture mapping. I made the cube, but also some other objects from my 3DO code software renderer, and I have to expand this a bit. So I think I have to do a torso. I have to do something real, not just a cube. And then I see, maybe with many polygons, I will realize that it's not as easy as I think. But I can definitely do, if I push something for the 286, even if there is more overhead, it will do much better on a 486, on 386 and 486. So maybe I can at least have something that runs well on later hardware. If you push very low and then you take your code high, I call this bottom-up approach. I had the term somewhere else. You can make something you target a low-end machine, it's going to be hard, but then you make something so fast that you run in higher-end machines, and it's like, oh my god, I can build a much more complex engine with that. But also you started from something very low. You started with a basic thing. And usually the other way where things can screw up, you have a modern engine. Maybe a modern software engine that you write on the Pentium. And you port it on the 386 and it can't even render a simple cube. You render a simple flat cube and it's like 5 FPS. That's how you see Pentium 2 demos. You know, this... forgot. Those replay demos. Artistic, flat shaded, they run like roll on my Pentium 1 and they display something that should run on a 486, not even 386, even 286. Some of the scene could be recreated on a 286. Maybe you can fake some layer transparency thing. But the flat shaded stuff, I don't know, man. We could do high-res demos on the 486, 480. You could do some artistic flat shaded thing, but run well on 486. You can do some high def thing on 386 where you render only parts of the screen. You render, you say my goal is to do some 480p demo on a 386. I'm not gonna render a full screen rotozoomer 480. I'm gonna do some artistic thing where I render part of the window, but the whole display will be 480. I can strategically render parts to make it impressive. Anyway, I think I should stop now. This became big and it's very... And I think my stomach was doing some things at some part of the video. Maybe you catch them, maybe not. I'll stop this crazy run. I don't know why I'm doing it. But don't worry, I'm not... I don't want to push anyone on how they should do or they should not do things. I guess people do. I've seen a lot of Unity, Unreal, and other demos recently, again and again. It's a lot of the graphics were done on Stable Diffusion and yeah, I mean things are moving and people are doing other things. Just those few of us who are fascinated by that retro kinda LARPing thing, but we could do LARPing better, you know, more hardcore LARPing. See you.